So our first step is to start a new case, and on our simulation basis manager page here we're going to add a fluid package. The fluid package we're going to use for this example is ASME steam, and on the components page we're just going to have one component, which is water. So with those two things added, we can enter the simulation environment. So we're going to add a material flow stream to our page, and if we look at the conditions of that stream, we're going to call it saturated steam because it will carry saturated steam. Stream pressure 2,800 kilopascals, and the vapor phase fraction is 1. So it's 100% vapor is what that means. And our mass flow is 72,000 kilograms per hour, which corresponds to 20 kilograms per second. And if we go to composition, our system only has water in it. So this stream is pure water. So it has a mole fraction 1 for water. And once we've put that in there, our stream is fully defined and solved for. And you'll notice that the temperature is fixed. So because this is saturated steam at 2,800 kilopascals, the temperature is fixed at 230 degrees Celsius. We cannot change that value. That's been calculated by HYSYS. So we can close that page. We're going to add a cooler to our simulation. So this is the cooler symbol, and we want to connect up that saturated steam, which is the inlet to the cooler. We're going to add an outlet, which we'll call condensate. So we're condensing that, and because HYSYS is going to do an energy balance over this unit, it needs an energy stream. So we'll add that in and just call it the energy stream. So I'm going to just move this one down a little bit to tidy that up. So if we look at our condensate stream, we're going to say that it's been cooled down to 80 degrees Celsius and the pressure is 2,800 kilopascals. So if you remember, that was the feed pressure to the unit. So we're effectively saying that there's no pressure drop across this unit. So now that we've specified those conditions, our entire system is fully specified, and you can see because these streams are now a darker colour that HYSYS has solved all of those. So to just have a look at it, if we look now at our energy stream, we can either hover over the icon here and we can see that the heat flow is 1.775 by 10 to the 8th kilojoules per hour, or 4.9 by 10 to the 4 kilowatts. So HYSYS has calculated that that is the rate at which we need to remove heat from this system to condense 72,000 kilograms per hour of saturated steam to condensate at 80 degrees Celsius. If we compare that value of 1.77 by 10 to the 8th kilojoules per hour with a hand calculation, they compare quite close. So in terms of kilowatts, it's 4.93 by 10 to the 4 kilowatts calculated by HYSYS, and we calculated 4.94 by 10 to the 4 with our hand calculation. And the small difference essentially arises from the difference in heat capacity. So HYSYS uses polynomials to calculate the heat capacity quite accurately, and in our hand calculations we use mean specific heat capacities.